Okay, looking at multiplication properties of exponents. Still have the same standard here, N.RN.2. Applying properties of exponents to rewrite radical expressions and expressions with rational exponents. We're getting there. Today we're going to focus on the second rule of exponents, which is power of a power. So rules for multiplying exponents here, our second rule, power of a power property, says this. To find a power of a power, multiply the exponents. So this time we have a power, which is this a to the m. This whole thing, remember, is a power. And it has its own exponent outside to the n power. And so we're going to multiply a to the m times n power, okay? So it would look something like this. And if we think about this as what our definition means, if we think about what a squared is as its power, the cubed out here is telling me, as my pen malfunctions here, that I'm going to have a squared times a squared times a squared. And that's what that means, okay? Because of the cubed. So I have multiplied a squared times itself 3 times. Now, if we continue with our definition of what an exponent is, I know that a squared is a times a, and each of these, come on pen, each of these is going to be an a times an a, and my pen here, there we go. And so at the end of this, as I'm multiplying, I have a to the first, second, third, fourth, fifth, sixth power. A to the sixth power. Okay, now similarly, I can speed this up by using my new power of a power rule, and I can go ahead and just multiply those exponents, and I end up with a to the sixth. So what we're going to find out as we work with these exponents is that there's multiple ways to look at each of these problems. And it all does boil back to our definition each time, but what our rules are telling us are just shortcuts to help us kind of speed up the process. So look at this example. Go ahead, pause the video, work it out, and when you're ready to look at the answer, go ahead and continue, and I will provide that answer for you. Okay, we're looking at y to the third, and then that to the fifth power. So I'm using my power of a power rule here, and I'm multiplying y to the 3 times the fifth, and that is going to be y to the 15th. Okay, we got some more examples here. Now we're going to ramp things up in difficulty just a little bit. The thing to remember, just like we talked about before, is that each of these terms is kind of its own separate thing. Each of these terms inside of the parentheses here is getting this third power. Each of them has that exponent. So what I would do is I would rewrite this as 4 to the third times x squared to the third times y cubed to the third times z to the third. Each term on the inside has just received this exponent on the outside of 3. And so now I can continue 4 to the third power. I'm just simplifying each of these terms here individually. And so 4 to the third is 4 times 4, which is 16. And another 4 times that is 64. And now I'm going to follow my power to a power rule. So I'd be taking 2 times 3, and y to the 3 times 3, and z to the 1 times 3. And my last step then would just be to multiply those exponents. So 64x to the 6th, y to the 9th, z to the 3rd. And we have simplified. This one is one last problem that I want us to look at, because this one is a little bit different in that inside of my parentheses now there is addition. So when there is addition, this is one whole term that I cannot simplify anymore. It is different than the previous term example that we looked at. In the previous example, notice how everything was being multiplied together. And so as I come down here a step, I'm multiplying everything together. but it is different when there is addition or subtraction inside of my parentheses on the inside. We will talk about that later in more depth, but for right now, this would be simply a plus 1 to the 2 times 5 power, which is a, whoops, not an x, let me start over there, which is a plus 1 to the 10th power. Okay, and just briefly, the reason why this does not work and I cannot make this a squared plus 1 squared on the inside here, I cannot distribute that into addition because then we are missing some terms, and we will get into that, like I said, later. So there are some examples for you to look at, and that will bring us to the end of this video.